In this video, we're going to learn how to utilize the zero product property in order to help us solve equations. Now, in order to utilize the zero product property, we need to think about what we know about the property of zero. So if you look up at the very top, you'll see a times zero, and a is any number. And what you should know about zero is that a times zero, any number times zero, is going to equal zero. That's just the property of zero and how it works when we have a product. So the zero product property stems from this knowledge, and it basically says if a times b is equal to zero. So say you have some hypothetical multiplication problem where a and b are some numbers. You don't know what they are. They're just some numbers. But when they are multiplied together, a times b equals zero. If that's the case, the only way for a product to equal zero, the only way for that to happen is if a equals zero or b equals zero. So that's what the zero product property tells us. It says if two numbers are being multiplied together and they equal zero, then one or the other, or both, are equal to zero. And we're going to use that knowledge to our advantage to help us solve some new equations today. So if you look closely at what you see on the screen, in this first example you see you have x plus 7 times x minus 1 is equal to 0. And while this might not look like the zero product property because it doesn't have a and b, this is really stating that a times b equals 0. That's what that's stating. A is equal to x plus 7, b is equal to x minus 1, and what this is saying is that a times b, whatever they are equaling 0. And we know that the only way for a product to equal 0 is if one of the components equals 0. So what we're going to do is we're going to figure out which values for x could make this equation potentially equal 0. The first thing is that this first set of parentheses could equal 0. So say we had x plus 7 and it equaled 0. That would make a equal 0, and so this would be 0 times something, and it would equal 0 automatically. So here, if we assume that this first parentheses equals 0, we set up this little mini equation and say, well, what would x have to be for that little parenthesis to equal 0? Well, we would have to subtract 7 from each side here, and x would have to be negative 7. So if x was negative 7, x is negative 7 would make this first parenthesis equal 0, and as a result, the whole statement would equal 0. But we have another option. While that first parenthesis could equal 0, the second parenthesis could also equal 0. We could have something times 0, and that would result in 0. So our other option is that x minus 1 is equal to 0. And we need to figure out what value for x makes this second parenthesis part equal 0. So here, if we add 1 to each side, we end up with x is equal to 1. So ultimately what we find here is we have two options for x. Either x is going to equal negative 7 or x is going to equal 1. And either one of these options, whether x is negative 7 and it goes in here and we have negative 7 plus 7 and this whole thing equals 0, or x equals 1 and we have 1 minus 1 and this whole thing equals 0, if we have x as one of these two values, this statement will be true because we'll have something times 0 and that will result in a product equaling 0. Now if we look at the second example here, we notice that we have a multiplication between 2x and x minus 4. So again, we have two things being multiplied that are equaling 0. So we really have a times b equals 0. And ultimately, we need to figure out, okay, what could x possibly equal that would result in this product equaling 0? And the first thing that could happen is that first portion there, that 2x, could equal 0. And if it did, we would divide both sides by 2 here, and we would find that if it did, x actually equals 0 itself. So this would be 2 times 0, and then it would be multiplied by that parenthesis piece, which would then make the whole thing equal 0. The other option we have is this second parenthesis part here could also equal 0. So we add 4 to each side. We find x is equal to 4. So here we have two options. If x equals 0, it will make this portion equal 0, and it will be 0 times something. Or if x equals 4, this will be 4 minus 4, which would also make this equal 0, and would ultimately result in a product equaling 0. So let's again use the zero product property here to figure out what the value for x is that could make these equations true. So here I notice that I have a product between 3x cubed and x plus 2, so two things being multiplied that equals 0. So that tells me that I can use the zero product property, and I can state, well, if their product equals 0, either this first part here of 3x cubed is equal to 0, or this second part here of x plus 2 is going to be equal to 0. One of those two parts has to be equal to 0 in order for their product to be 0. So then from here I begin to solve my little mini equations. I get x cubed is equal to 0, which seems really tricky, but then if you think about it, the only thing to the power of 3 that would give you 0 is 0 itself, 0 times 0 times 0. So for this first option, if x equaled 0, then this portion would equal 0, and it would be 0 times some number, and that would equal 0. The other option, if we subtract 2 from each side, is that x would equal negative 2. So here we have our two options. This first one here makes this portion equal 0. This second one here makes this portion equal 0. And if one of those two portions equals 0, then we will have an equation with a product equal to 0. Now if we look at the second part here, what I notice is I have two items being multiplied and equaling 0, so I can apply the zero product property. So I set the first part equal to 0. I have x minus 3/4. That could equal 0. Or 6x plus 3 could equal 0. So I solve the first one by adding 3/4 to each side. So I have x could equal 3/4. Or I subtract 3. I get 6x is equal to negative 3. Divide by 6. Or my other option is that x equals negative 3 over 6, which I know is just a negative 1/2. So those are my two options for x that will make this equation true. So in these two examples, notice that we have three items being multiplied. So I have x plus 2 times 2x minus 5 times x minus 4. But the nice thing is the same property applies. We have something times something times something equals 0. That is the zero product property. And as a result, we go through the same process. We just simply set all three items equal to 0. And we figure out what makes each one of them equal 0, because we could have either one of those three things equal 0 and the whole product would equal 0. So as a result, I solve each little mini equation. So here I find x could equal a negative 2 is one option. Well, then I add 5 here, so I have 2x is equal to 5, divide by 2. Or x could equal 5 over 2. Or x could equal 4. So either one of these three options would make the above equation equal 0. So then final example here, I notice I have 3 times 5 minus x times x plus 2. So again, I notice I have three things being multiplied and they all equal 0. So that means zero product property. So from here I then look and I can set each component equal to 0. So I have 3 equals 0, 5 minus x equals 0, and x plus 2 equals 0. So then from here I move forward and I solve each different little mini equation for 0. What I notice in this first one is that there's no x value. So there's no way for that part to equal 0. That's false. So as a result, I can ignore this and say, no matter what I pick for x, that little mini equation there will never equal 0. Then from here in the second one, I can utilize keep change with a 1. So I start by subtracting 5 from each side. So I have negative 1x equals negative 5. Divide by negative 1. So I find x is equal to 5 as an option. And then from here, I'd subtract 2. So here would be our x is equal to negative 2. So either one of these two options will make this original equation true.